Hello everyone. So welcome to Leetcode 26 day challenge. In this we have a question like design a data structure in which we can add and search words. So we have to make our own data structure in which we can add and search the words. Suppose we are given like we have to add these all words like bad, dad and mad, and we have to search something like this. So in searching we can be given full stops in the beginning of the words which we are searching for. Like let's say like we are given AD, full stop AD. In this full stop AD, this starts with a full stop. So this full stop can be occupied by any character from A to Z. Like suppose if we are having like AAD in our data structure already, and if the user is searching for full stop AD, then we will return a true because like we are having a word that has AD and that has one more thing. Okay, so we will be returning a true in this situation. So this question can be solved by using try data structure, and by doing a DFS on tries we'll be able to solve this question, and I will be showing how we can solve this problem on my black. So as I mentioned earlier that we have to use a try data structure. So the prerequisite for this question will be that you need to have a clear understanding of try data structure, and without the knowledge of tries you won't be able to solve this problem. So the first work which we'll do is that we'll make a try, and we will add all these words in our try. So the question was to add these all words and to search for these all words. Okay, so first we'll add these all words in our try. So this will be B, and then B will be making a reference try for A, and then A will be making a reference try for D. This will be false, this will be false, and this will be false. So if you already know what tries data structure is, then you are in this, then you will be able to understand that why I have added this as false. And after this, the D will be having a reference of true. Now we'll add dad in this. So for that we will be making another D, and then we will be adding A, and for A we will be adding another D, and they will be false, and the reference try for D will be true because the sentence has completed, the word has completed. And then we will be adding mad. So again we will be doing M, and then we will doing then we will doing the reference try of M. So that reference try will be A, this will be also false, and then A will be again having a reference try of D, and this will be also false. And now the word has ended, so we'll be having one more reference try, and this will be true. Okay, yeah, so this is the try we are having. Now let's search for pad P. So we are not having any, so this is our root. So we are not having any word in our root which starts with pad, which starts with P actually. So we'll straightforward return a false, that pad doesn't exist. Now we'll be looking for bad. So is there any B existing in our root? Yes, there is a B. So we're going in the reference of B. So the reference of B is A. So are they equal? Yeah, B and A are equal. So then we'll be going to the reference of A. So that will be D. Okay, yeah. But the problem will come here when we will be having a full stop. So for full stop, what we'll be doing is we'll be doing a DFS. We will actually see like if there is a full stop, then we will be going to all the possible references that the current node has. Like in this case, we have a full stop over here. So we'll be going to all the possible reference tries of this full stop. Like if we will be going to this try, we'll be going to this try, and we'll be going to this try. And from here onwards, we will be searching that is there anything which we can get, like for example A. So yes, there is A possible in here. There is A possible in here also, and there is A possible in here also. So after that we will be doing the same thing, but for these full stops we will be doing our DFS, and we will be checking for all the possible options that we have. And in the case of B, what we can do is like we're searching for the B reference. So we have the B reference as this, but after that we have a full stop. So we'll be searching for all the possible options of A. So A only has one possible option, that is this. So we'll be going in this direction, and then we'll be again having a full stop. So we'll be going in this direction, and finally we will be reaching a true. So this means that we have completely finished this sentence, and this will be returning me a true, this last one. So this is how the tries, so this is how I will be doing the try operation. So for code I will be, so now moving on to the code part, I will be coding it in C++. So now let's talk about the coding part. So first of all we need to make a try structure. So let's just make a struct node, and it will be having few links. So let's make links, and there will be 26 links because there are 26 English characters, and we'll be having a flag, bool flag, and by default it will be false. Okay, yeah. So there will be a few functions in this try, like inserting. So first we'll make like insert, like void try insert, and this will be getting a character char ch, let's say, and we have to insert this character. So as you I expect you might be already knowing that we have to insert in links, like we have to make a reference try. So we'll be adding it in my character ch in my link. So that will be this minus a, because I'm converting it into like 0 to 26, and that will be equal to a new node. I'll be just assigning it to a new node which I'm just creating. Okay, then I have to also check whether that particular character is present or not, because if it is present then we don't have to create a new node, but if it's not present then we have to make a new node. So let's just create a new, let's just check whether it's present or not. So let's just name that function as try contains, and this will be also having the char ch, the character, and let's just return that whether the links of my CA equals to null. So if that is equals to null, so this means that there is no such character. So if I just pass it the and of this, so this will work, right? Because this will say that if it is equals to null, so that means it is not present. So contains is false. This is true. So if this is not, this is false, like it doesn't contain this particular ch. And now let's come to this part, like coding part, main part. So here we'll be just making our root. Let's make it private. It's a nice convention to use it as private because we don't want other functions to manipulate my root's value. So let's just make my root equals to a new node, and that's it. And now let's talk about the adding part. So adding part is very easy. Like we have to add all the words in our root. So that will be, I'll be making a temp equals to root, and then we'll be just like writing for auto ampersand I in words, and then I'll be checking if first of all I'll be checking whether it contains. So first of all I'll be checking whether that particular character is present in my try or not. So for that I'll be checking that whether my temp of whether was a function name, it was try contains means I. So this will say that whether it contains this particular I or not. So this will be actually false, because suppose a character is not present. Okay, suppose a character is not present, so this will be true, like this part will be true. So now this will be becoming false, and now if this is coming false, so this means we have to insert it. So that's why I'm converting it into true. So once it has been converted to true, then we will just inserting it like this, like temp will be equals to try insert and I. So we have just inserted the value. Okay, and then we will be moving our temp to the reference node. Like we have inserted a node, and now we'll be moving our temp to that particular reference node. So how will we doing that? So for that we will be just writing temp is equals to temps links I minus a. So this will take my temp to that particular link where my reference try is there present. Okay, and in this way we can just add all our words, and obviously at the last we have to put the flag value as true, because there are true particular marks that our particular word has finished. So we'll be just writing temp flag equals to true, and that is exactly how we'll be writing our addWord function. So now let's move to the searching part. So searching part is little bit complicated. So first we will be passing a dummy parameter over here, which will be actually storing the temporary node address. I'll be explaining what it is doing in a moment. First, let me just write it. So let's just call it temp node, and let's just assign it null for the moment. Okay, null for the moment. And let's make another node like temp, and let's just say it unnull. Okay. Now if my temp node equals to null, if it's equals to null, so this means that I'm like starting my search. Means I'm at the particular root. So if my temp node is equals to null, so my temp will be equals to root, because if my temp if it is equals to null, that this means that we have just started our operation. So that's why we will be just assigning root value to our temp. Okay, and once we have done this, we have to check the else part also. Like if this is not true, then so we will be just making our temp equals to temp node. So I think you would have already understood what this temp node is. So this temp node is actually the kind of particular that it is like at that particular moment where are we, like this is the root of that particular moment, because as I said this is a DFS call, so our temporary node will be keep on changing. So we won't be so we should not change our main root node. So that's why we are making this temporary node, because this value only will be changing. So this is why I'm using this temp node. So let's just first iterate over the entire word we have for auto ampersand I in. Now let me just iterate over the entire word, like for int I equals to 0, I less than word dot size I plus plus. Okay, and once I've done this, first I'll be checking like if my word of I equals to a full stop. If it's a full stop, then we have to do our DFS, but if it's not a full stop, then it's very simple. Like we have to just check whether that is present in our try or not. It is very simple. Okay, so first let's talk about this part. Like if there's an equals to, sorry, if there is a full stop. So if there is a full stop, then we will be checking that for which particular reference node we're having a full stop. Like there will be 26 reference nodes for every single try node. So we'll be checking that which particular reference node is having our null value. So let's just run our loop from int k equals to 0. Let's say k less than 26 and k plus plus. And if I just find out that the temp of links of k equals to sorry, it's not equals to null, this means that we have something over here. Right? So we will be just checking if this search of that particular word. So now we have just divided a word. So first we will be like checking the substring of it. So word dot sub str I plus 1 comma word dot size minus I. So I hope you understand why I'm doing this, because I've checked for all the words which have already occurred. Now I have to check whether the words which are remaining are matching or not. Like if I'm getting a full stop, so I have to check that all the words after the full stop are matching or not. So till full stop I have omitted all the words, and after the full stop I am like considering all these words. And as I think you are already familiar with the DFS thing, so I'm just like passing it to this function recursively, like I'm doing this again and again. So that's why I'm just changing the parameter of it. So I just changed the word, and now I'll be passing my link. So for link part, I'll be just writing temp links k, and if it is like if we get that word, so we just returns true, because we found it, so no need to go further. Let's just return true. Okay, but if we are not finding anything, like if there is not even a single value of this which satisfy this particular condition, so we can just like return a false, because we won't find it anywhere else, because none of the none of the reference tries are satisfying the condition. Okay, so now let's come to the else part. So else part, it is very basic, like just what we can do is like if my temp try contains my word of I, then I will be just making my temp go to the reference try, means the reference try of word of I minus a, and if it doesn't contains it, I'll be just returning a false, and at last I will be just returning the flags value, because suppose we have a very long word, and like suppose we have apple, apple, and we're searching for app, so this all will work because we have found all the suffix of it, but app is not equals to apple. Okay, so we have to check that whether the flag value is true or not. So if everything has worked, so we'll be checking whether the value of the temp flag equals to false or true or not. So if it is equals to false, so that means we have not found the word. Like I gave the example app and apple. So for app all these things will work, but here we'll be finding that the p is having the flag value as false. So we'll be just returning the false, otherwise we'll be returning true. So this is how the code looks like. Let me just run my code. A little correction over here. So I just forgot to write here else. So just include else, like if this condition is working or else this condition is working. So now let's try to compile my code and let's try to submit it. So let's submit. So this is how you can solve this problem. So this is just a very classic example of tries. So thanks for watching this video, and if you have stayed till here and if you found this video to be useful, please consider subscribing, because this will give me a lot of confidence to make more such videos.